we have to relate the interference pattern and the diffraction pattern. The difference between interference and diffraction is here there are only two sources, point sources in the interference. And they could be at a distance a or any distance d or a, whatever. Here the distance, the slit, there is one slit and it has a long slit of d. So here what happens is if you have two point sources and there's a path difference, this is the path difference. If this path difference, which they relate to the point on the screen, x, uh, path difference is equal to x d by d. If this path difference is n lambda, what will happen is it will be like this one wave coming and at covering 5 lambdas, the other wave from the other source covering 6 lambdas, there's a difference of 1 lambda. And if there's a difference of 1 lambda, they will come in phase and it will be bright spot. Here it's slightly different. If you have a long slit, if you have a long slit which has a very uh, uh, there will be many sources. So if there's a difference of lambda between the last source and the first source, you might think this will have construction. No, the so many sources here that they will divide into two, with each having a phase difference of lambda by 2. Now that means this will balance, construct, destroy this will destroy this, and so on. These, so it will become dark here, even though the first and the last are 1 lambda apart, but they will there are so many in between who are silencing each other half lambda separately. So this is dark here in. So see the difference in diffraction. When here the path difference is d sine theta. If this is equal to n lambda or 1 lambda, let's say, you basically get the darkness here. So n by d, you say n by d, n lambda by d is sine theta. At these points you will get darkness. Here it's slightly different. Here at this x, when becomes n lambda d by d, you get brightness. So here if d is the distance between the 2 points, and you have a same case where you have a slit of this length, you will, in diffraction you will get darkness, here you will get brightness. Is basically because of the, this was the question which had come for a single slit of width. The first slit of width, the first minimum of the interference pattern of a monochromatic occurs at, so this is a slit. So this is basically talking of diffraction. And at the same time, angle of, we get a maximum of two narrow slits. So if there are two narrow slits, this is interference. This is Young's double slit YDSC, Young's double slit superimposition. And so this is interference pattern. So this is interference, this is diffraction. He says at in interference you will get a maximum, in diffraction you will get a minimum. And he says for a single slit width, that means long slit, the first minimum of monochromatic light occurs at this. So this is darkness, because they have half of wavelength, each destroying each other. Whereas in a double slit experiment, this is interference produces maximum, because one wavelength difference of in phase, and so maximum bright spot. So please try to understand the difference, compare and contrast the difference. See how here you are getting maxima only at the center. Here you are getting minima. You are getting minima at lambda by d. Here you are getting maxima at lambda by d. Yeah, this will be maxima. This is lambda by d actually. Of course, this capital D. This is the angular. I'm talking of the angular separation. And then the other thing you have to notice is when the path difference. And these are we relate the angle here. In diffraction, we are only relating the angle. So in diffraction, we relate the angles, because d sine theta, we have related d sine theta. So theta to where it will get, at what theta you'll get a maximum. And if there's, like in this case, when theta is 0, so they all come in same phase, so it's maximum. When it's supposing 3 lambda by 2, so this will destroy this will destroy this is lambda by 2 difference lambda. But these will be separate. So when there is 3 lambda by 2 here, then these parts won't get destroyed, so it will be bright. But because it's some part has been destroyed, that's why the intensity goes on decreasing. That's why in this they are showing you that the intensity is going on decreasing. See, the intensity goes on decreasing because some part is destroyed. Here it's in phase. So please see the comparison of all of this. In the interference pattern, if there's a difference of lambda by 2, that means there it is destructive because they are out of phase. One wave is coming like this, the other wave lambda by 2 means 180-degree out of, they destroy, they it becomes flat. But here it's slightly different in the diffraction pattern. In the diffraction pattern, it is slightly different. If it's like here he's saying 3 lambda by 2, here he's saying 3 lambda by 2. So we have odd multiples of lambda by 2, we get brightness because one lambda by 2 is left, the others cancel out each other.